Hello, this is just a quick video to introduce and to demonstrate Coltraco Ultrasonic's brand new and improved Portasonic PRO, now with built-in gauge pressure, heat flow calculation, data logging and totalizer functionality. For those of you already familiar with our Portasonic PRO, you might notice that the UI has had a considerable redesign, and we've done this to simplify the process of connecting, setting up the device, and to allow you to view all of the most important metrics of your flow in one place without having to navigate to different screens or to scroll through large lists of values. You'll see also we now have a totalizer field, which is one of the first new features that I'll talk about, and this simply allows you to measure not only the flow rate in seconds or minutes or hours, but also the total flow that has flowed through your system in a given time frame since you start that totalizer running. And finally, we have all of our settings and installation parameters are now stored in this sidebar that can be accessed from anywhere on the device simply by swiping in on to the right or tapping these three dots on the left hand side. Now for the demonstration, I'm going to be using this pipe here, which I've already input all of the parameters for accurately in the installation details, but I'll show you how you do that now. So you see we have pipe, I can tap on the pencil edit icon, and I could change the material, the roughness of the material, the outer diameter and the wall thickness, and I'll also mention we have expanded the database of materials that you can use for your pipe considerably, and we've also implemented an other option where you'll be asked to provide a speed of sound and a roughness for that material. Again, in our case we are just testing on PVC, so I can go ahead and select that. Then within fluid, we have a drop down to select the type of fluid you're testing and just the temperature of that fluid. Once again, we've expanded the database of fluids considerably, so there are far more to choose from than in the original version of this device. And we also have an other option here for any not in our database, where you'll be asked to provide the speed of sound, the density and the viscosity of that fluid as well. Once again, this pipe does just have water flowing through it, so I'll leave that as water. And then for our transducer, you can see we have the DM10 sensors, which are our standard sensors, which I will be using for the demonstration, and our mounting method or number of passes, which I have set to 8, means 8 passes of the ultrasound through the pipe. We can choose any value from 1 to 12 for this. I'll stick with 8 for this particular demonstration. And we also have here a transducer spacing field, which isn't user input. That will be read from the sensor once all of these parameters have been written, and that will tell you how far apart your upstream and downstream transducers should be placed. And finally, in this sidebar, you can see we have our quick settings panel, which has toggles for metric versus imperial units. It also has toggles for data logging, pressure calculation and heat flow calculation. Right now these are all turned off, but you see I'll turn data logging on so that we can show you the data logged file afterwards, and we'll call this demo. I will also turn on our gauge pressure calculation, where we'll be asked to enter a pipe length and an exit and an entrance height. And then finally we have calculate heat flow toggle, which I'll also turn on, and this will ask you for an inlet temperature and an outlet temperature, and it will calculate the exchange of heat in or out of your system based on these two temperatures. So I've got this set to 25 in and 18 degrees out, and these values are just arbitrary, this just for the demonstration. But once those things have all been enabled, you'll see when we go back to our main screen, we have 2 additional fields just here for gauge pressure and heat flow rate, which will be populated when we start measuring. Now to start measuring, it's very simple. All we do, we uncover our USB connector at the bottom of the tablet here, and we simply plug in our sensor. And when we see this icon switch, we know our sensor is connected, and it will start reading the waveform and some values. Right now all of these values are 0 as our sensors are not placed onto the pipe. So what I'll do now is I will quickly go to my installation details. I will check my transducer spacing, which you can see has now been populated at 89.5 millimeters. So to install the sensors, all we need to do is take a bit of ultrasonic silicone grease, which will be used to couple the sensors onto the pipe so we get good transmission into our system. So I will take a small amount of silicone grease, apply it to the sensor, and I'll take one of our beaded chain clamps, which is used to fix the sensor securely onto the pipe. Place it onto the wall of our pipe, place the flat barbed beaded chain clamp into the groove on the sensor, and then pull round. I will pull to tension the spring. I will slot the bead into the groove on the flat plate, and I'll get that position nice and straight. Then I'll take a tape measure. I will get a rough idea of where my other transducer should be placed, which is around here. I will once again apply a small amount of silicone grease to this, and I will place it with my arrows facing in the same direction, for now just roughly in the right position, and then I will adjust this with the tape measure once I've tightened up the chain clamp. So I'll fasten this on, get it in place. It's quite important to make sure that the transducers are as well aligned with one another as possible, as they'll be transmitting ultrasound and receiving, and if they're misaligned you might miss those reflections. So I'll measure again. See, I'm slightly further apart than 89.5, so I'll just give it a small nudge forward. Quick check to make sure everything looks nice and in line, and once we're happy with that, we can simply take our sensor and plug into the device again. It'll connect, and once it's connected you can see we have a waveform appearing on the graph now, and all of our values are starting to update. In this case our ATA ETA is pretty good at 99.1, 99.2%. This should be as close to 100% as possible, and the way to change that is just by making very small adjustments to the position of these transducers. So I can move them very slightly further apart or closer together, and that's just going to change, that's just going to help us position the sensors exactly correctly for our setup, so that we can get the most accurate readings. However, with something like 99.1, 99.2, typically that would be absolutely fine. We stipulate within 3% of 100, so 97 up to 103% for your ATA ETA should be good. On the totalizer, to start totalizing and recording the total volume of flow, all I need to do is press start, and you'll see that value will start ticking up. So that's just going to keep ticking over, and it'll update every time we take a measurement. So I'll hit stop now because we don't need to see it anymore. You can see we've got our gauge pressure being calculated right alongside our flow speed and flow rates. Heat flow as well, which is being calculated currently in joules per second. I'll change this to kilojoules per second. And finally, I'd like to just show you, since we've had our data logging turned on, if I now tap on view and export logs, we should see we've got a demo.csv file right here, which I can choose to select and then export via either email or USB. Within these records as well, you can actually sort them by size of the file. You can sort them by name alphabetically, or in reverse order, and you can sort them by date, newest to oldest or oldest to newest.